of the webinar series Space for Youth, organized by Students for the Exploration and Development of Space, University of Sri Jayewardenepura. My name is 𝗄𝗶𝘁𝗵 Pereira, and I will be your moderator for the day. The topic that will be the focus of today's webinar is astronomy as a career and exploration of space. On March 21st, 2022, the International Astronomical Union formally named an asteroid Colombounilanka. Our guest speaker for the day, Dr. Nalin Samarasinha, along with the fellow astronomer Dr. Todd Lauer, found this asteroid back in the year 2000. This was a notable moment for us as Sri Lankans, as this was the first time a scientist of Sri Lankan descent was credited for naming an asteroid. Dr. Samarasinha obtained his Bachelor of Science in Physics from the University of Colombo, graduating with first-class honors in 1981. He received his master's degree in astronomy from the University of Maryland at College Park in 1985 and his PhD in 1992. His research interests are focused on the study of comets and other small bodies of the solar system. Studies done by Dr. Samarasinha include understanding the physics and chemistry of cometary nuclei, the structural properties of small bodies in the solar system, the rotational and physical properties of trans-Neptunian objects, and the physical properties of asteroids. Dr. Samarasinha currently works as a senior scientist for the Planetary Science Institute in the United States. He is known to serve as a research mentor for many undergraduates and graduate students, and is active in outreach activities. He also acts as a co-investigator on many outreach grants. Dr. Samarasinha, we warmly welcome you to address the gathering.
Thank you very much. Can you hear me?
Yes, sir, we can.
Okay. Thank you very much, 𝗄𝗶𝘁𝗵 Mayura and SEDS Jayewardenepura for inviting me. So I will today talk about basically two parts to this talk, astronomy as a career and exploration of space. Hopefully I will finish my presentation in less than 30 minutes, and then I will try to answer the questions that you have. So, when talking about astronomy as a career, first I will talk about my experiences, and then I was asked to talk about the discovery of asteroid Colombounilanka, and then I will talk about basically it will be an overview of astronomy as a career. During the second part of the talk, I will talk about space exploration, which is a multidisciplinary exercise. One may say astronomy itself is multidisciplinary. My experience, I started school in the mid 60s, long time back. First, I attended a small school in Mount Lavinia. That time it was called 𝗄𝗶𝘁𝗵 Vidyalaya. Actually, I started attending the kindergarten at that time, just 1 year after the school was started. It started that actually, some of you may have heard 𝗰𝗰 that is where the first few months, I believe, the school was located, and then moved to a permanent location. And then I was there until grade 8. And then I went to Nalanda College for my O-levels. Those days, O-levels are grade 9 and 10, and then A-levels 11 and 12. So for O-levels, when I was doing taking O-levels from grade 9 itself, students were divided into science stream, commerce stream, art stream, etc. In fact, not only that, the physical sciences and biosciences were also started in grade 10. So basically, I didn't do biology, for example, even though I was in the science stream as an O-level subject. There were 8 subjects at that time. So then I did A-level, basically physical sciences. There were 4 subjects, pure maths, applied maths, physics, and chemistry. And then I went to University of Colombo. There I got selected to do physics special. And after that, I was able to get a first class. And then after 1 year at the university, working as a temporary assistant lecturer, I got an opportunity to come to United States. I joined University of Maryland as a teaching assistant. So teaching assistant means you will be doing tutorials or labs for students, undergraduate students, and you will get paid a stipend. So that is sufficient to basically live as a graduate student. It is a comparatively small amount, but that is sufficient. And then I got my master's. Actually, master's was not necessary, but since I completed the requirements, I applied for master's and then completed PhD. And this was in the late 80s. I was working on my PhD. In fact, that was the time, 1986, Comet Halley had its apparition. The word apparition is used whenever the comet comes close to the sun and Earth, of course. So the 1986 apparition of Halley was not fabulous. It was a comparatively dim object. It was a dim object. It was, at least with my eyes, I could not see it even from a dark location. It was, for those who are little familiar with magnitudes, which is a measure of the brightness of a celestial object. It was around 4th magnitude, and it is a diffuse object, a comet. So that means the brightness is distributed. Therefore, it would be harder to see than a 4th magnitude star. Anyway, part of my PhD work was on Comet Halley. I worked on the rotation of Comet Halley, It was in what we call a non-principal axis rotation state in more easy language, one may say it is sort of a tumbling object. Then after that, after my PhD, I went to do a postdoctoral work at National Optical Astronomy Observatory. They are the ones who basically operate all the US government-owned optical telescopes. They have two facilities. One is at Kitt Peak in Arizona, and the other one is, at least at that time, in Chile, Cerro Tololo Inter-American Observatory. But now it has a different name. It's called NOAA Lab. So I was there for about 15 years or so. After that, I basically joined a non-profit research organization called Planetary Science Institute, again headquartered in Tucson, Arizona. But there are scientists throughout the US, and there are few outside US too. Mostly planetary scientists, and planetary scientists could be either coming with an astronomy background or strong geology background. So there are basically two pathways for somebody to become a planetary astronomer. I mean, sorry, a planetary scientist, a planetary astronomer, and a planetary geologist. Because we need geology background, especially we have so many missions to planets, comets, asteroids. So in order to explain the geological phenomena, you need that. So that is why at the beginning itself, I said astronomy is also sort of a multidisciplinary exercise. So planetary astronomy can be considered as part of astronomy. In fact, the American Astronomical Society, AAS, it has different divisions, and division for planetary sciences is the largest division of the AAS, American Astronomical Society. So, so that is my experience, and it is probably quite typical, I would say. But later on, I will talk about some of the astronomers from Sri Lanka who took careers or pathways which is a little different to that. But of course, the common thing is first you have to do undergraduate degree, and then you have to do a graduate, in Sri Lanka you call postgraduate degrees, and masters, and ideally PhD. So that is how one would become a professional astronomer or astrophysicist. Next I will talk a little bit on Colombounilanka. This was an asteroid that which myself and another colleague discovered nearly 22 years back, specifically on November 30th, 2000. So This was discovered at 𝗰𝗶𝘁 National Observatory. So this was discovered while we were observing some other object. So it was given a provisional designation, and then after 22 years, or almost 22 years, there were sufficient number of observations from multiple people and multiple observers, mostly from sky service, which scan the sky looking for asteroids. There were sufficient number of observations to improve the orbit, and the orbit is fairly well known by early this year. So International Astronomical Union assigned a number. So once a numbered asteroid is there, the discoverers will have the option of naming it. And I talked to my co-discoverer, and I wanted to name it for University of Colombo. So there are a lot of rules naming asteroids. So for example, if somebody wants to name an asteroid after a politician, you had to wait at least 100 years after the death of that politician. So that is a rule. So the rules are pretty tough. Even I settle on this particular name based on the rules. And one thing I want to point out, when we discovered that most of the new asteroids were discovered by sky surveys, which were looking for asteroids, mostly near-Earth objects, near-Earth asteroids, or near-Earth comets. So that is how it was discovered. Basically, we were looking at that object, and when we have taken multiple images, we saw this object moving with respect to the background stars. That is how you generally discover an asteroid or a comet, for that matter. And so we know only its brightness, how efficiently it would reflect sunlight, we don't know. Because of that, we cannot have a very accurate size estimate. It should be about 1 to 2 kilometers, and we don't know anything about its shape or rotation state at this time. However, as I said, its orbit is well determined, and it is in the middle of the main asteroid belt. It orbits around the sun every 4.2 years, and always this object would be more than 1.4 astronomical unit from Earth. Astronomical unit is the distance between the sun and the Earth. So that translates to about 200 million kilometers. So there is no danger of it hitting Earth. So we don't have to worry about it. Then I will talk a little about the difference between astronomy and astrophysics. Because these two terms you may have heard. So when you say astronomy, in a strict sense, it is the study of celestial objects and various phenomena. Basically, you take the measurements of a celestial object in the sky. And if you do that, that is basically astronomy. But application of physics to interpret astronomical observations, then it will become astrophysics. If you go back 300-400 years back, it is almost always it is astronomy. But nowadays it is mostly astrophysics, because we apply physics to explain what we are going to observe. So typically people use the terms interchangeably, but the difference is what I mentioned. And as I said, planetary science can be considered a branch of astronomy. I mentioned to you, if you want to become a professional astronomer, you need to have undergraduate degree and then graduate degrees. And typically most people have their undergraduate degrees in physics, but sometimes they can have it in other fields, such as geology, chemistry, computer science, and even biology sometimes. So there's the option of pursuing a graduate degree in astronomy, even with different undergraduate degrees. So when you look at astronomy, there are different branches. There are solar astronomy or solar physics. Then there is planetary science, as I mentioned. Then if you are studying stars, it is stellar astronomy. And then if you are studying galaxy, you have galactic astronomy. If you are studying other galaxies, you have extragalactic astronomy. And then cosmology, which is the origin and evolution of the universe. And astrobiology, that is looking for conditions, for example, needed to have life elsewhere in the universe. So there are different branches, and typically most people study astronomy in graduate school. That means as postgraduate work. And another thing which I want to point out is modern astronomy is multidisciplinary. You need physics and mathematics. Sometimes not those two are not sufficient, and you need computer science, especially if you are doing planetary science. You may need geology background, sometimes chemistry. And also astronomy is related to many other disciplines, such as space exploration. And there are many nations have space agencies. US has NASA, then Russia has Roscosmos, European Space Agency, and some of European countries have their own space agencies. Then Japanese have JAXA, the Chinese have CNSA, then India has ISRO, and even United Arab Emirates, they were had a recent Mars mission. So not only big countries, sometimes even small countries have space programs which are related to astronomy. And there are a lot of direct benefits associated with astronomy, which you might not realize. One is image processing. image processing had a lot of starts in astronomy, but now there are various other applications, for example, medical applications to find tumors and stuff like that. Then various imaging devices, CCD cameras, infrared cameras, etc. Then error correcting mirrors, lenses. You may have heard adaptive optics, which has applications in communications. And then, of course, big data, so which involves handling and analyzing large amounts of data. And naturally, there are many spin-offs associated with space exploration. So, astronomy is relevant to Earth and its environment too. If you look at space weather, effects on Earth's weather, how it would affect orbiting satellites, communications, and then studying other planets, we will learn about comparative planetology, how tectonics, geomagnetism, geochemistry, seasons, clouds, cyclonic activity, lightning, hydrology, astrobiology, those aspects would vary from one planet to another, and we will learn about the whole process. And of course, if you are an observational astronomer, one benefit is you have the option or the opportunity to travel to various observatories for example, places like Chile. I enjoyed going to observatories like that, and then Hawaii at I think it is something close to between 13,000 and 14,000 feet, and so there are many observatories. Sometimes these days you can do remote observations too. And I mentioned that I want to point out the career paths of astronomers, astrophysicists of Sri Lankan origin. There are differences for people like Dr. Asoka Mendes, who is retired now. He basically did his PhD in the UK, and then he came to USA and he worked in the US. And then Dr. Kavan Ratnatunga, he did his graduate work in the US as well as in Australia, and then for his postdoctoral work and his research work he has done after his postdoc, he has done in the US. And then Dr. Tilak Hewagama, actually I want to mention about him. He is the only Sri Lankan astronomer, Sri Lankan origin astronomer, who is a NASA civil servant. And he works on various missions, infrared astronomy, planetary science, solar astronomy, multifaceted. And one thing I want to point out, he did a general degree at University of Colombo. So just because you do a general degree doesn't mean your opportunities are completely shut off. You have to find the opportunities. If you are coming to the US, that is what Tilak did. You have to do GRE and other English exams. And then basically, you can pursue what you want to do. And then there are others like Dr. Jayewardenepura, who is at Cornell right now, Dr. Asantha Kure, who is at University of California, Irvine. They came to US, they got scholarships for undergraduate studies. And so they did their undergraduate in the US, and then their graduate work too. And also Dr. 𝗰𝗁𝗰𝗁𝗰𝘁, who is a cosmologist, she's in the UK. So she, I think she did her undergraduate in the UK, but then she worked in the US, and then she went back to UK. And then Dr. Gayanthe de Silva, she did her PhD in Australia, and then had postdoctoral work elsewhere, and I think she is back in Australia. So then there are a lot of other astronomers. Another person that I should mention, Dr. Prasanna Deshapriya. He did a master's in Vietnam, and then he did his PhD in France. So you have to be innovative to find opportunities. So if you want to do, you can do. But also, I should mention that a lot of people wants to become astronomers. So it is a very competitive field, but the way which I look at, there are, I know a lot of colleagues who have left astronomy after their postdoctoral work, but you will not be jobless. You will not be jobless because you have various skills when you do a astronomy PhD. So you can use those skills, computational skills, and if you have done projects related to big data, you can apply those in other fields. So I know people who are working for banks, then even Wall Street, doing financial modeling. So there are opportunities, but if you don't find a job that you really want, but you are willing to go and do work in a non-astronomy area, there are opportunities. And I'm running a little behind. So let me talk a little about space exploration. So when you say space exploration, it involves remote observations with telescope by astronomers and astrophysicists. So it could involve robotic exploration of space or human exploration of space. And of course, it is the next frontier. When people started from, humans started their journey from Africa, they spread throughout the world, and then they found new continents, and now humans are exploring beyond our own atmosphere. So that is basically space exploration. And robotic space exploration requires expertise of many fields. So, for example, you need aerospace engineers, electrical engineers, many mechanical engineers, many kind of engineers. Then you need physicists. For example, Dr. Sarath Gunapala at NASA JPL, he's an infrared detector development. That is his expertise. And so there are different kind of people, and astronomers or planetary scientists such as Dr. Tilak Hewagama, they are only a small part of the space exploration enterprise. And of course, if you go to human space exploration, that is even more complex. And then one thing about robotic space exploration is even small countries can do it, and there are low-cost alternatives. But of course, comes with those low-cost alternatives, there are limitations. There are small sats such as CubeSats. For example, typical CubeSat, 1 unit costs less than 100,000 US dollars. So there are a lot of observations you can do, both astronomical as well as looking at Earth. So there are a lot of opportunities in space exploration, and there are a lot of benefits to humanity, which is true for astronomy, astrophysics, as well as space exploration. All these are very powerful tools to motivate children to pursue scientific and technical careers. As I said, it involves scientists and engineers from multiple fields. So actually that is good because it will have cross-pollination of ideas. And then there are technological and scientific spin-offs such as medical applications, agricultural and climatic applications, consumer products and safety, transportation, information technology. So there are multiple aspects to it. And so my suggestion is identify your goals, even if it is not space exploration or astronomy, and then focus on persevere. You can accomplish, and you may have to think outside the box, and you will succeed. So I will stop talking and I will try to answer any questions that you may have at this time.
Thank you, Doctor, for that insightful talk. Now the floor is open for questions. If you wish to ask the question yourself, click on the raise your hand icon and I'll read out your name, or you're always welcome to send in questions through messages and I will read out the question. Doctor, we already have one question. They want to know how to become a space doctor in NASA. What are the qualifications they are expecting? Yeah, they basically want to know what the qualifications NASA expects.
So it depends on what area. Now, typically, if you want to work at NASA, again, I want to point out there are two categories of people who work for NASA. NASA civil servants, that means they are NASA employees. So they are getting paid directly by NASA. And then there are NASA contractors. So there are companies which tell NASA, okay, we will do this particular one, this particular task. And so NASA contractors, so that particular company might have different qualification. So typically, if it is astronomy, it is a PhD. But if it is engineering, it could be even masters, because I know some people who are of Sri Lankan origin, actually they were directly coming and doing graduate studies, and then ultimately ended up working for NASA, the engineers I'm talking about. Sorry, I think the connection was lost. I was talking about if you are interested in working as an engineer, especially with masters, you can have opportunities to work at NASA. But one thing, you have to satisfy what they are looking for. So that is the criteria. And of course, it is difficult directly for a non-US citizen to work for NASA, but first you can work as for a company which is subcontracting. I mean, there are various ways that people have done. When I say done legally.
Doctor, some other questions along with the NASA question. People want to know, is the pathway the same if they want to become an observational astronomer at NASA or an astrophysicist at NASA? Is what you said the pathway the same, or do they need some extra qualification?
Actually, NASA employs only a very small number of astronomers. But most astronomers, when I say astronomers slash astrophysicists, they work at various universities. There is that name recognition that some people would like to, but other than that, I mean, there are a lot of good astronomers at various universities. You can work at various universities it need not be at NASA because it is a very small percentage of astronomers who work at NASA. I'm not trying to discourage, but I'm trying to point out the reality.
So there's a question. I would like to become an aerospace engineer, an astronaut, and an astronomer. How can I achieve all of them?
Okay, that is tough because I know only very few, a very small percentage of astronauts are astronomers. Like shuttle missions, there is a very small percentage. And I know at least, I think it is true even now, there are various requirements. I know a colleague, he could not, he realized he could not become an astronaut. He wanted to be an astronaut because his eyesight was not perfect. And so right now he's a accomplished astronomer. So you have to sometimes change your goals, because if you have a physical drawbacks, and if they really require, but I mean, I don't know what would happen or how would things going to be in another 10 or 20 years, because now even some disabled people, they are talking about the possibility of making it available to become an astronaut. So so becoming an astronaut and astronomer, you have to have really persevere. There are a lot of conditions which needs to be satisfied. I'm not again trying to discourage anybody, but the reality, it is very tough, and I wish you can become one, and even though the odds are very small, don't get discouraged. So
Sir, another question. Can I know the exact path when we name an asteroid? Because yes, they want to know how what path to follow when it comes to naming an asteroid.
what do you mean by path? The orbit of the asteroid? Or?
I think the process, yeah, the process of naming an asteroid is what they're
asking. Process of naming an asteroid. Okay. The process is, if you have discovered an asteroid, typically the discovery credit is given if you have observations from 2 different nights at least, and you are the first one to observe. And right now, for an individual astronomer, it's extremely hard because it is very much less than 1% of all the newly observed, I mean, the newly discovered asteroids are discovered by individual astronomers. Most are discovered by sky surveys, because the sky surveys are there looking for asteroids. And so they basically 99 point whatever percent they discover. However, I think even SEDS Sri Lanka is partnered with Pan-STARRS and Catalina Sky Surveys to identify asteroids in their images. And then if you discover a new object, you will get discovery credit, but it might take a number of years until its orbit is accurately determined. There are various categories. Ultimately, it has to have a zero level accuracy. Zero level means still the orbital elements which defines the orbit has certain have different they have finite errors, but it is very well known. So we can predict its location in the future to a very high degree of accuracy. So then only Minor Planet Center, they give a number. Right now, there are more than 600 asteroids with which are numbered. And so once it is numbered, the discoverers will have they will get the discovery credit, and they following the guidelines, rules and guidelines set forth by the International Astronomical Union, can submit a name. And as I said, if it is going to be named after an individual, it cannot be a politician who is alive. But for a scientist, I mean, there was an, for example, asteroid named after me in 2002 in recognition of my contribution to comet science. And then there are a number of Sri Jayewardenepura, who is actually Dean Science and Arts at Cornell University. There's an asteroid named after him. And then Prasanna Desapriya has an asteroid named after. So those are astronomers. And then students who come first or second in the Intel Science Fair, the linear sky survey, they have decided to name asteroids. In fact, there are a few Sri Lankan students that I think 2, if I'm not mistaken, asteroids named after, one was from Ananda and one from Meentale Central. So asteroids named after those 2. So the discoverers will have the option of naming an asteroid. So that is the normal process. And also sometimes International Astronomical Union has competitions to bring awareness and make it more as a part of astronomy outreach to suggest names and citations. And of course, it is not guaranteed that what you suggested will get selected.
So another question, why do so many people choose NASA when there are so many other space companies like ESA and SpaceX? And it's followed up by, does NASA pay well for an astronaut compared to other space agencies? And what could be the salary of an astronaut at NASA?
Okay, multiple questions. Okay, probably NASA has the name recognition, and so European Space Agency, they have multiple missions, and actually Prasanna Deshapriya, which I mentioned, he did actually part of his PhD work on Rosetta mission to comet 𝗄𝗶𝘁𝗵. So he was at working or studying at in France. So he was not working there initially, but as a student first. So it was an ESA mission. And also, one thing to realize is there are NASA instruments aboard ESA spacecraft, and similarly NASA instruments on board Japanese spacecraft, and European instruments on board US spacecraft, that means NASA spacecraft. So I think NASA is, it is the name recognition, like when you're talking about various commercial items, you use the most common brand name, just like that. And the salaries, salaries, typically in the US, salaries, they specify salary per year. So if you are starting, it could be less than 100,000 US dollars. And then if you are at a very senior position, maybe 150, maybe even close to 200,000 US dollars. So that is how the rough idea. I mean, it depends on the experience, your particular expertise, and things like that. And one thing, most of the, I mentioned most of the astronomers work at universities, and just like in Sri Lanka, university professors may not get the highest salaries in the country. So even in the US, it is the same case. But I mean, at least the way which I look at, you get a decent salary, and salary is not everything. So if you are looking at money, one should not do astronomy. You should start a business. But I mean, it is job satisfaction you have, the opportunity to do what you would like to do in your life. So all those things, I mean, should be factored in.
Speaking of starting a business, sir, the next question is, I have an ambition to be an aerospace engineer and start my own space exploration company. after getting some experience by working in SpaceX. Is it a good career path as a Sri Lankan, and what are the best universities to learn about aerospace engineering?
What is not clear, are you, or the question specifically refers to starting a company in Sri Lanka or company elsewhere? That is the question. Because if it is in the US, for example, first, probably before starting, you may have to become a US citizen. Of course, it is much easier to start if you have a physics background, right? You can, I think you can, you have opportunities of doing aerospace engineering in the US because I know, in fact, a colleague which I collaborate a lot with, his undergraduate degree, and actually he had a master's in aerospace engineering. So basically, you look at the same region of the sky. That means you have the same background stars. And then you take an image about an hour or so after that. So you have the same stars. And then you take another image, again, the same stars. So you have those stars at the same location. And you basically blink between the frames. So when you blink between the frames, that means going from one frame to another frame to the third frame, all the asteroids or comets or even planets, our objects in our solar system, they will start moving. So that is how you discover. So unfortunately, there's an issue with the media player. I'm sorry.
No, it's okay, sir. So the next question is, how can I become a planetary geologist? I am an undergraduate in mineral resources and technology, which is related to the applied earth science.
Sorry, undergraduate where?
She hasn't specified, sir, but her degree is on mineral resources and technology.
Oh, okay, I see the question. Okay, yeah. I'm an undergraduate in mineral resources and technology degree program. If you have a geology related degree, then you can basically apply to go to a university to do a graduate degree in planetary science, because there are a lot of planetary geology programs. In fact, I can mention somebody who was from Sri Lanka, received his PhD recently, Dr. 𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁𝗁 And so I believe it was University of Wisconsin, one of the campuses, University of Wisconsin system. That is where he got his PhD. He had an undergraduate degree from Peradeniya, geology. And then he had a master's from planetary geology. And so that is how he did it. And I would suggest that you contact Dr. Gayantha Kodikara. You can do a Google search, and probably he would be able to give a better answer than me, because I came from the astronomy side, whereas he came from geology side.
So the next question, where do comets originate?
Okay, good question. Both comets and asteroids were formed in our solar system. They were the leftover objects from the solar system, sort of fossilized history, so to speak. When I say fossilized history, there were some changes happen, but by and large, compared with planets. Asteroids were formed close to the sun, and comets were formed further away, because comets have ices and dust, whereas if you take asteroids, they were mostly rocky objects. What happened, those icy objects which formed, starting from area around Jupiter all the way beyond Jupiter, and some of those objects, they were thrown out during the initial stage of the solar system, because there were a lot of things going on it was a very dynamic environment. In fact, Jupiter, all the giant planets, Jupiter, Saturn, Uranus, Neptune, they moved. That is our current understanding in the solar system. I would encourage you to look at something called 𝗰cie model of the solar system. 𝗰cie is named after 𝗰cie Observatory, NICE. A consequence is that all these, most of these objects in the giant planet region, they were thrown out to what we now think is called Oort cloud. So Oort cloud is a hypothetical cloud around our solar system, but it is 50,000 to 100,000 astronomical unit away from the sun. And then beyond Neptune, we have the Kuiper belt objects. So, and part of the Kuiper belt is called scattered disk. So there could be some migration between the Kuiper belt objects which are close to the plane, and the scattered objects are which are more inclined. So there may be some movement between one objects in the one category of objects to the other. But basically, those are two reservoirs, the Kuiper belt and the Oort cloud. So those are considered to be the source regions for comets. So, but they originated in the outer region of the solar system. But some of the comets coming from the Oort cloud, they have the orbital parameter which we identify as the eccentricity. So if you are looking at an ellipse or a parabola or hyperbola, there is a quantity called eccentricity. And so they have eccentricities close to 1, but less than 1, little less than
1. So the next question, how often does an asteroid fall outside of its specific asteroid belt?
It's not uncommon. And that is why we have what we call near-Earth objects. And if you look at moon, you will see there are a lot of pock marks. So all those craters, most work happened during the early stage of the solar system. But even now, Earth's atmosphere is basically preventing us from those asteroids hitting us, especially the small ones. Hopefully, no big one would come and hit us. That would be pretty bad. But a small percentage can move close to Earth, for example. So those are called near-Earth objects or near-Earth asteroids, if it is an asteroid. Or when you say near-Earth objects, it could be asteroid or a comet, which comes closer to Earth.
So the next question, when we see a space object, how do we know that it is, if it is an undiscovered one or a previously identified one?
Oh, good question. There are multiple places where you can go and see whether that object is a known object or a new object. For example, NASA JPL site. There's something called, if you go to SSD, Solar System Dynamics Group at JPL, ssd.jpl.nasa.gov, if I remember right, the URL. There are various tools where you can look at, okay, this is the part of the sky we are looking at, and what objects are in that part of the sky at a given time. So we can know that accurately. In fact, and then Minor Planet Center has another one. Basically, that is what we did when we saw these moving objects in our field 22 years back. That is the first thing we did to make sure that it is something already discovered. So apparently it was not. So
so the next question, can we mine asteroids?
Yes. In fact, there are even private companies, they're talking about mining. So the idea is to mine especially some metals which are comparatively rare. So it involves a certain amount of technology, and it has to be economically viable. So the second thing, the economic viability will also depend on whether you have the right technologies developed. But yes, there are number of companies which are interested in mining asteroids. And my guess is probably in few decades, it will happen.
So the next question, were there any instances when asteroids actually turned into comets? And has an asteroid ever hit the sun?
Yes, the answer to both of those questions. Let me explain. Actually, there are objects called main belt comets. Those are, first, let me make a little clarification. Observationally, a comet, this is purely from an observational point of view. A comet, an object is called a comet if we see a coma. That means coma is an escaping atmosphere of the object. Escaping because its gravity is so small, unlike planets. So that is the definition of a comet. So some of the asteroids, asteroids can collide, even though it don't happen that often. Asteroid collisions are happening all the time, especially in the asteroid belt. So then if it spew some of the dust into that into the space, then we define it as a comet. But also there are some asteroids, main belt asteroid. There is a comet called 133P 𝗰𝘁. That was observed to be little active when it comes close to the sun. The closest point to the sun is called perihelion. So since it is happening multiple times when it is close to the sun, we think it is due to ices sublimating. Sublimation is going from ice to gas phase. So that is what we think. Yes, there are asteroids turning into comets. When you say turning into comets, it is part to do with the definition. And the other thing is we like to divide things, but I think it is really a continuum. So when you have the asteroids without much volatiles, that means without much ices, and then comets with a lot of ices, but some dust too. So when you go from one end to the other end, so where do you draw the boundary? So that is basically related to that. And yes, asteroid will hit the sun, and comets hit the sun too. That is not uncommon.
So we've got another question. What is your personal idea about Planet 9? Do you think it exists?
Okay. Historically, the Planet 9 was not the same thing. If you go back 100 years versus now. So it has changed. And for example, when Pluto was discovered, it was the search was done thinking that Neptune's orbit showed some weird behavior, but it turns out there was no weird behavior. So Pluto was not changing Neptune's orbit as it was expected at that time. But at the same time, I want to make a small clarification. Pluto is in what we call 2 to 3 resonance with Neptune. That means when Neptune goes around the sun 3 times, Pluto goes around the sun twice. So these resonances are very common in the solar system and also in exosolar systems. So that is if one wants to study celestial dynamics, that is another branch by itself. So there could be another planet, but so far we don't have definite answers. And do you think it exists? If it is far enough, probably. I mean, even now, to explain some of the orbital properties of Kuiper belt objects, I should say distance objects, the idea has been put forward, but you have to wait and see.
So what is the Apollo group of asteroids?
There are a number of groups of asteroids. They have certain orbital properties. Now, top of my head, I can't remember the exact conditions. They satisfy certain conditions with respect to Earth. So Apollos are defined, for example, there is another group called ATENs, ATEN. So there are a group of asteroids like that. And then there are asteroid families. Asteroid families are thought to be asteroid which had an impact and then it got broken into. So those are called asteroid families because all the family members share more or less the same orbital properties. And typically you have to have 6 orbital elements in order to explain the orbit. So Apollo group is one such, it's not a family, but it's a group of asteroids like ATENs.
So about the asteroid mining, is there any chance of it succeeding in the near future?
I think so. The big unknown here is near future. So I don't know. Near future means how many years, but probably in a few decades, yes. Because this can be done robotically. Because I can remember when I was at your age, basically, or before your age, I was, it was in the late 60s and 70s with the space program. So there were a lot of talk about before 2000, people going to Mars, but there were a lot of technical human biology related issues which need to be resolved before humans go to Mars. But if you are doing robotically, it is much easier and much cheaper. So that is why I say probably in few decades, don't ask me whether it is the next decade or 3 or 4 decades, but I think it will happen.
So how frequently do comets and asteroids pass the Earth, and how do astronomers know which asteroids or comets pass by Earth?
Okay. Many asteroids and comets we know of. As I mentioned, there are more than 600,000 numbered asteroids, and there are observations of over 1 million asteroids now. And so the ones which are not numbered, but we have some information about the non-numbered asteroids. Even their orbits are reasonably known. And also a lesser number of comets, of course, we know about. And so that is how we know. And also there is a new survey coming up soon called Vera-Rubin Observatory, named after an astronomer, Vera-Rubin. And there's a survey, that is a survey telescope. It is called LSST. One can do a Google search, LSST survey. And so that is going to discover during the next decade or so a lot more asteroids and comets. So the reason is that will look at much fainter objects than the other existing surveys. So and then once we know, have multiple observations, we can calculate the orbit, and then we can calculate how close to Earth they would come. So, and of course, there may be new ones coming close to us too. And especially if there is a new comet coming from Oort cloud, we may not know until few months or few years before it comes. For example, there is a new comet which is around 150 kilometers across, which is huge compared with the typical comet sizes are concerned, but which was discovered sometime back. And that is going to come only up to the orbit of Saturn. So even though it is huge, it will not come close. But on the other hand, a few years back, there was a comet called Siding Spring, which came, if my memory is right, something little over 100,000 kilometers from Mars. And if, remember, it is closer than the distance between Earth and Moon. So if a comet comes that close to Earth, that would be fantastic viewing opportunity, but also we had to be careful that cometary dust, for example, can cause Earth orbiting satellites. So there are multiple aspects to the problem.
So what causes the gaps in the asteroid belt?
Okay, good question. These gaps are called Kirkwood gaps. So if one does a Google search on Kirkwood, Kirkwood, you will see the gaps. Those gaps, most of those gaps are resonances with Jupiter. So in the case of the asteroids at these resonances, orbital resonances, they are unstable. So that means if an asteroid is at that gap, one of the Kirkwood gaps, it would either move one way or the other way. So because of that, you are not going to see a lot of asteroids at that Kirkwood gaps. So those are the gaps. And on the other hand, if you look at the orbital distribution, I wish I have slides ready for to show what I'm really talking about. Hyperbelt. Hyperbelt also, there are orbital resonances with Neptune. So I already told Pluto is in 2 to 3 resonance with Neptune. That means Neptune goes, when Neptune goes around the sun 3 times, Pluto goes around the sun twice. So there are other objects in that 2 to 3 resonances. They are called Plutinos. So those resonances, there are more hyperbelt objects at those. So resonances play a huge role in determining the architecture of asteroid belt or Kuiper belt. Also, how a comet would migrate inward from, say, Oort cloud or from the scattered disk of the Kuiper belt.
So the last question we have for you: how can scientists determine the composition and the atmosphere of planets very far away from our solar system?
Okay, to determine the composition, you had to take a spectrum. So when you take a spectrum, so typically, if you are thinking about optical imaging, there are 2 main ways. One is imaging, and then you can use a spectroscope, and you can basically spread the light coming from that particular object. So you can basically see the brightness versus the wavelength. So by looking at the spectrum, we can tell what chemical species are there. So sometimes certain minerals, they have characteristic signatures. So that is how we can determine the composition, looking at the spectrum. Oh, somebody has posted the link for the Kirkwood gap.
Yes, sir.
Thank you.
So that's all the questions we have for you today. Thank you so much, sir, for joining us and taking time off to deliver this insightful discussion and talk to us. We appreciate it a lot, sir. So that brings us to the end of this session. Thank you to everyone else also for joining and participating. We hope to see you with another webinar session like this in the near future.
Thank you very much for inviting me, and again, when you have your journey, whether you want to be an astronomer or involved in space exploration or anything else, as I said, focus on, persevere, and there may be roadblocks. But if there is a roadblock, always there's a detour that you can take. So I wish you all the best. Thank you.